What's up, Joel? So you're now going to be learning about the distance formula. The distance formula is very similar to the aspect of slope and midpoint formula, meaning that we still use x2 and x1, y2 and y1, okay? Knowing that there's two x's and two y's. And so the subscribes 1 and 2 represent the first and second x and y values. So looking up here, this is our distance formula. We have parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared. We add those together, and then you have to make sure you do the square root piece at the end to get our official answer, right? A lot of people get confused with the distance formula, midpoint formula, meaning that inside we subtract, but up here we add our x and our x1 and x2. Down here, we subtract our x2 and x1. So you have to make sure that you're subtracting with distance formula, you're adding with midpoint formula. One thing I also mentioned, it does not matter if you do x2 first or x1 first, as long as you keep it consistent, right? So if you do x2 first, you have to do y2 first. If you do x1 first, you have to do y1 first, okay? So quickly, let me kind of explain why this works. We're kind of pulling back in that Pythagorean theorem idea, a squared plus b squared equals c squared. And why this is the reason why that is that the Pythagorean theorem applies because a right triangle can be constructed with the length of the hypotenuse equal to the distance between the 2 points. And so what happens is that when we are trying to do this formula, what we're actually doing is we're doing from b to this point right here is our x2 minus x1. And then from this point to C, we're doing our y2 minus y1. And so if you kind of see, it creates this hypotenuse, or this right triangle. And then what we're trying to find in the end is we're trying to find this hypotenuse right here, right? That's what we're finding when we're doing the distance formula. So let's go ahead and walk through this. First, you have to make sure you know the points. So B is at 0, 1, and C is at 4, 3. And so let's go ahead and just slowly plug these into our equation. So let's go ahead and do x2 first. So 4 minus 0. And then let's go ahead and make sure we square that. You're also going to add with your y. Let me move this over so you can see it. Y2 is going to be 3 minus 1, and we also have to make sure we square that as well. So let's kind of walk through this. 4 minus 0 is 4. 4 squared is going to give us 16. And so let's bring my square root in. So we have 16 here. Plus 3 minus 1 is going to give me 2. 2 squared is going to give me 4. And so now we are here. And then you just had to say, okay, 16 plus 4 is going to give me 20. The square root of 20 is going to be about 4.5, I believe. Let me double check. The square root of 20. Yep, about 4.5. So that would be our answer for the distance formula. If it's looking for it to be in Pythagorean theorem setup, just so you know, if it's asking to be in the Pythagorean theorem setup, you would leave it as square root of 20, okay? That's kind of very, very rarely are they going to ask for that adding, but if you look here for the question, it says Pythagorean theorem format. And so in reality, our answer should be the square root of 20, okay? But very rarely are you going to get that idea that it's asking you for the square or the Pythagorean theorem setup, okay? Go ahead and do this. Find it on your own. I just want to see if you remember how to do this, but find the midpoint and the length of the segment with endpoints 2, -4, and -3, 1. Give it a shot, see what you get. If you have any questions, let me know, but that's the distance formula. You can go ahead and do the activity for today. Let me know if you have any questions, Joel.